Now we will think about the transmission of electricity. You might have seen very big transmission lines where the electricity is carried from the generating station to the cities. So we are using very high voltage for transmission. Actually, very high voltage is used for transmission of electricity in order to reduce the loss of power during the transmission. That's why this 110 kV or 220 kV, like that voltage, very high voltage is used. And we will use AC also. You study in 10th standard AC and DC. So we are using AC because we have a device called as transformer. Using this transformer, we can increase and decrease the voltage. So this is possible in AC. So why we are increasing? How we can save the energy by increasing the voltage? That point we will discuss now. Now let us consider a cell. There is an electrochemical cell like this. So in this cell we have some electrolyte is there, and we have two electrodes. Here one electrode is there, here another electrode is there. Let this point be A and this point be B. So we can see here when this point A is there, here there will be a potential VA. Here we have another potential VB. So if we connect this one with a resistor like this, a current will flow through this one from A to B. Now you see here, why the current is flowing from A to B? Because the potential of A, that is VA, is more than VB. So from a higher potential to lower potential only the current will flow. So the current is flowing from a higher potential to lower potential. So VA, that potential of A should be more than potential of B. So if you take the potential difference, that V is given by potential of A minus potential of B. So this should be more than 0. That is, this one should be greater than, that is VA should be greater than VB. Now you see, if the small charge is passing here, delta Q, the charge delta Q passing can be written as I into delta T. That is, charge is equal to current into time, which we already know, or current is equal to charge by time, like that we can write here. Now here and here we have some potential energy also. So the potential energy is given by Q into VA. What is Q into VA? This is the potential energy of this charge at A, and at B it will be Q into VB. So this is the potential energy at here, and this is the potential energy here. Now when it is moving, there is a change in the potential energy. That will be the difference. Here the potential energy is Q into VA. Here the potential energy is Q into VB. So what will be the change in potential energy when it is flowing? That is given by delta U potential. That is, change in potential energy is equal to delta Q into VB. That is the final, minus delta Q into VA. So when you take the change in potential energy, final potential energy minus initial potential energy we have to take. So this is given by delta Q into, within bracket we can write VB minus VA. So here we can see this delta Q I am writing same here, delta Q. But this VB minus VA, how we can write? VA minus VB is our V here. So this will be minus V. So I am putting a V here and a minus sign here. So change in potential energy is given by minus delta Q into V. Now you know that this change in potential energy is given by delta Q into V. There is a minus sign also. So this value should be, delta Q can be written as I into V into delta T. That is, this V is capital I large H, and this delta Q we are writing as I into delta T. And there is a minus sign, that also we will put here. And we know as it is flowing, the change in potential energy should be positive, then only it will flow. So change in potential energy should be positive. That is, this value should be, definitely it should be, it should be negative, because from higher potential to lower potential only it is coming, and here we have the negative sign also. So this should be less than 0. Now if you take the change in potential energy and change in kinetic energy together, so what will be the change in kinetic energy? If this is change in potential energy, negative of this one will be change in kinetic energy. So delta K will be minus delta U potential. That is, how much change is there in potential energy? The same amount change will be there in kinetic energy also, but there will be a minus sign. So this is the change in potential energy, means what will be change in kinetic energy? The same with potential, same with another sign. That is, instead of minus sign, it will become plus sign. Okay, now our delta K, this value here, you see this is less than 0, means this should be more than 0. So this change in kinetic energy is equal to I into V into delta T, which should be a positive value. So that point is very, very important. This change in kinetic energy is a positive value. Now you see here, we studied about the work done in junior class, where it is work done delta W is equal to this change in kinetic energy. Change in kinetic energy is same as work done. So I into V into delta T. So this is the work done. Change in kinetic energy is same as work done. Now if you take power, what is power? Power is work done by time. So if you take here, it will I into V into delta T by delta T. So power is equal to I into V. So this is the equation which you studied in 10th standard. So this is how we are getting this equation. So derivation once more, we can check this one. Now the same thing you studied in 10th standard using Ohm's law, V is equal to IR. If you substitute here, you will get other equation also for power. P is equal to I square R, or P is equal to V square by R. These things you studied in 10th standard. This one also you studied in 10th standard. So how it is coming, that derivation part you not studied. So our main point is, our power is given by three equations. Power is I into V, or power is equal to I square into R, or power is equal to V square by R. So once more, if you read this by step in your textbook, it will be very clear how you are getting this equation. Now, just getting this equation alone will not take you to the final result. Now, if you think about a particular city, you have a particular city here. This is a city area. Here you have the power station. So this power station to city, we are taking the electricity through some lines. So we have some power lines there. So through that power lines, we are taking the power there. Now, when you take this power, there will be some power loss, because these lines are made up of copper or aluminium, whatever. Even though they are good conductors, there will be a small resistance. So due to this resistance, these wires will heat up. So how we can reduce the heating effect of this one? That's what we have to discuss now. Now you see here, if it is, this city is using a power P here, P is the power used by this city. So we can write power is equal to V into I. Now in this conductor, this will heat up. When it is heating up, some energy is wasted or some power is wasted. So that power I am writing PC. This PC means power wasted in the conductor. That will be I square into RC. So I square is I is the current passing through the conductor, and R is the resistance of the conductor, RC. Now you see here, what is this I? This I is the current passing through that one. So how much current will pass? That we can take from this equation. So what is current there? I is equal to P by V. So what is the difference between this P and this P? This is the power used in the entire city. This PC is the power lost in the conductor. So this PC can be written as, from here you take this one, P square into RC divided by V square. So this is very, very important. So when you are using a power in a particular city, how much power is lost in the conductor, that depends on the value of V. That is, it is inversely proportional to V square. So what is the meaning of that one? If you want to make the power loss minimum, how we have to go for a transmission? We have to use the transmission line in which the voltage is very, very high. That's why in our, if you check anywhere, you can see some towers, big towers like this. In this one, we can see the electrical lines are going. Such towers you might have seen. So these towers, they are using a very high voltage of 110 kilovolt or 220 kilovolt. So our transmission lines always uses very high voltage. Why we are using very high voltage? When the voltage is very high, the energy lost during transmission in the power line, that will be very less. So in order to minimize the power loss in the transmission line, our transmission voltage should be very high. So in this here, when we are producing the electricity, we are not producing the voltage as that high. We are producing a low voltage only, and we are using low voltage also. But during the transmission, in order to avoid the heating up of this line and wasting the energy, we will use it in a very high voltage. So that point is very important. So why high voltage is used for transmission means, its answer is this one. You have to write this equation and you have to tell the power lost in the conductor is inversely proportional to the voltage square. That's why if you use high voltage, the power loss will be very less. After reaching here, again we will reduce this one, that you will study in another chapter. By using the transformer, we will reduce it. Here also, in order to increase also, we will use a transformer. So the main point is, if you use very high voltage, the transmission loss will be very less. So the voltage is increased and decreased by use of transformer.